Or here, moving the mic 1/4 of an inch at a time does nothing. A little movement, little to no change. The same little movement, still little to no change. But at some unexpected time, the same little movement which had gone unnoticeable before, this is the part of a complex system that I think is really fascinating. How come it goes here, but not here? Wow. Anyway, this is the part of the system that I find really fascinating, is thresholds, or really terrifying if I happen to be in the test tube. It is the likely presence of tipping points in our climate which make the game of climate change so dicey, or perhaps we should say, so Russian roulette-y. The nerve-wracking part is, we've recently learned enough to have very strong suspicions that the Earth's climate has tipping points, but because of the unpredictable nature of chaotic systems, we can't know where they are. We can say that the farther and faster things change, the more likely we are to cross one. But tipping points really can only be identified from the other side. Oops! I guess that's where I should have stopped. This is where that picture of climate as an angry beast is coming from. In fact, recent research seems to be showing that in the measurable past, there have been only 2 periods of climate stability, one of which humans grew up in. You might think, ha, change is inevitable. See, I told you it was a natural cycle. Well, sure, on a geologic timescale it's inevitable, like tens of thousands of years, but we have excellent evidence that CO2 is a forcing which may trigger another abrupt climate change sooner than it would have otherwise happened. So yes, it's inevitable that the climate will change, probably drastically. But we seem to be what's making the difference between whether that happens 20,000 years from now or in 2020. That's the difference between it happening to you and it happening to your great, well, you get the picture. Plus, dying is inevitable too, but you still dodge the bus, right? So how do we know it's not just a freaky coincidence that the climate is changing observably at the same time that we are observably putting more greenhouse gases in the air? Because remember, just the fact that 2 things are correlated doesn't mean that one causes the other. Remember the pirates and global warming example? So how do we know it's not just a freaky coincidence? Maybe the climate is warming naturally, just at the same time that we happen to be making markedly increased amounts of emissions, greenhouse gas emissions. How do we know it's not natural, caused by the sun or cosmic rays or clouds or the Earth wobble? The Earth's axis wobbling. The simple answer is, no peer-reviewed study or model or graph has been able to reproduce the observed warming of the last 20 years without also including the forcing of human-caused carbon dioxide emissions. Go look that up yourself. Don't believe me. There is no scientific explanation, that is done by scientists rather than armchair commentators, of what we observe now in the physical world that does not incorporate human forcings. When you hear that old saw about "it's the sun, stupid," go do some looking, and you'll see that that hypothesis is a contender for much of the 20th century data, but totally falls apart for the last 20 years. Plus, no one contends that the sun does not affect climate. It certainly is one of the factors. But the picture seems to have become clear that the sun can't explain the warming by itself. But then, what do I know? I'm not a scientist, and this stuff is really hard to understand. If you want competent analysis of a complex scientific issue, go ask the trained professionals who know how to properly interpret the data. I think they probably got a few of those over at AAAS or NAS. Maybe they published something on the topic. Oh, that's right. The Pentagon report I mentioned earlier specifically warns of such abrupt climate change. The research suggests that once temperature rises above some threshold, there's that word from complex systems, threshold, adverse weather conditions could develop relatively abruptly, with persistent changes in the atmospheric circulation causing drops in some regions of 5 to 10 degrees Fahrenheit in a single decade. Drops of 5 to 10 degrees in a single decade from global warming? Remember, that's why global climate change is a better phrase. Better still, climate destabilization, or climate chaos, or how about just global climate cluster? So what exactly is the threshold temperature at which it all hits the fan? We don't know. We can't know until we've hit it, because tipping points can only be identified from the other side. Nervous yet? We know it's possible because it's happened before. 12,000 years ago, long before SUVs, the globe warmed 9 degrees Fahrenheit in, guess how long? You got it, a decade. That's what I've been saying, some skeptics have told me. The climate has always been changing, so why are we suddenly the bad guys? Wait, that story is comforting to you? That because the climate has gone totally cattywampus in the past, therefore it can't be us doing it now? What about the fact that it can lurch so far so suddenly? 9 degrees in 10 years? Don't you find that just a little disturbing? And anyway, isn't that reasoning sort of like socking your sister in the arm in which she complains to mom saying, you know, that arm has really been a problem for her in the past, huh? So clearly I'm not involved. Well, I'm sorry to break it to you, but here's the bad news. Remember that idea of a forcing in a complex system? In the past, it was a change in solar activity or a wobble in the Earth's orbit that provided the poke that sent the climate spinning off into a new state. Well, this time, we are the forcing. We are the poke which threatens to send the climate lurching to a new state. But how can we, puny little us, do such a big thing? Well, remember, with a complex system, the poke, the forcing, doesn't have to be big to have huge effects. It just needs to be in a ticklish spot to set off feedback mechanisms, which then amplify the change, setting off more feedback mechanisms, and so on. And in this case, we are providing the forcing by digging up 300 million years worth of buried carbon in the form of oil and coal and putting it into the air in the space of a couple hundred years. This is why we should be talking more about climate sensitivity than amount of warming. And as far as I can tell, this is indeed a shift that's happening in the climate science community. I think it also is why the newer research seems to be making the IPCC's predictions seem too conservative, perhaps way too conservative. Because newer research is showing that there are a number of possibly very significant climate feedback mechanisms which weren't incorporated into the IPCC's climate models. So it looks like history may end up judging the IPCC's predictions as being way off base, but off base in the direction of being too mild. That's not good news. One last feature of complex systems that seems a little contradictory is that of lag time. On the one hand, you hear talk about abrupt change, but on the other, there can be a significant lag time between cause and effect, simply because the system is so large with so many interactions that chains of cause and effect take a while to play themselves out. What that means is that you've got to look way ahead if you want to anticipate the changes. This doesn't contradict the characteristic of abrupt change, and in fact, it makes for a nasty combination. Here's why. As an analogy, think about a large ship. It's very easy to oversteer. If you don't know what you're doing, it's easy to just go way off to the side and way off to the other side. Here's why. You want to turn left, so you spin the wheel a little bit to the left. The ship doesn't seem to turn because it's got a lot of momentum that's hard to change. So you turn the wheel more. Still going straight, so you crank the wheel harder. Now finally, the ship starts to turn a little bit. But this is the turning that resulted from you spinning the wheel the very first time, 4 spins ago. So now, when you stop spinning the wheel in response to the ship doing what you want, there's still a bunch of your spins stacked up that are going to be affecting the ship over the next few minutes. So you end up turning very sharply to the left because of all your stacked up turns. In a sense, abruptly once it happens, though there was a long lag time after you first turned the wheel. And it's the long lag time that allows you to stack up the inputs, contributing to the magnitude of the abrupt change that eventually happens. With the ship, you panic because you're turning way too hard to the left, so what do? You turn way too hard to the right, making the same mistake the other direction, but worse, and off you go in a wild zigzag over the next few minutes, communicating to all salty hands that it's a landlubber at the helm. Now I want to be clear, don't think we can take that analogy and then use that as an argument against action on climate change, saying, well, then if we try to counteract climate change, it'd be like that big ship, and we'll end up going too far the other direction, end up in an ice age. Well, we're not talking about steering the other direction. What we're talking about in taking action on climate change is letting go of the darn wheel. We are causing a forcing by putting out all the carbon. The action is to stop doing that. So there's not going to be any oversteering or overshooting because we're not going the opposite direction. We're not talking about climate engineering and space mirrors. We're just talking about stopping the forcing, taking our foot off the gas, letting go of the wheel. Watch the solutions video and mechanics of climate change for more specifics on that. You know those big supertankers, the biggest ships on the planet? I haven't talked to a pilot firsthand, but I've read that they start their turns miles ahead of when they need them. As a physics teacher, I have a keen sense of inertia, and that picture sounds reasonable to me. So in a sense, our climate, with its complex interactions, lag time, and huge amounts of matter and energy, is like a huge ship, and we're turning the wheel with our greenhouse gas emissions. The problem is, we're not looking miles ahead. My fear is we won't look up until it's obvious to the most casual observer that we're in trouble, and at that point, it may very well be too late to avert the shipwreck. Even if we can, it will take Herculean effort because it takes a huge amount of effort to make the same turn in a short amount of time that smaller effort made earlier could have accomplished. So now we get to the meat of the boogeyman, where we can get a sense of why there are such drastic predictions resulting from a little bit of projected warming. What it basically comes down to is potential feedback mechanisms in the climate. We'll take a brief look at just a few of these to get a flavor. There's a ton out there, so you go do some Googling if you want to find out more.